Hello, guys. This is the 10th part of our lecture series, Becoming a Lead Green Associate. I remain your friend, Opayemi, and in this segment, you're going to be looking at indoor environmental quality, IEQ, indoor environmental quality. Join me as we go through this lecture. Thank you. Yeah, for our content under this subject, we will consider indoor air quality. We'll consider lighting as a subject and also occupant comfort, indoor air quality, lighting, and occupant comfort. So let's look at the overview. For indoor environmental quality, the goal is facilitating health and well-being. This is a crucial factor when it comes to designing indoor spaces because a number of parameters such as air quality, lighting, thermal control, acoustic design, which has to do with sound, and occupant comfort are considered. These strategies are aimed to promote the health and well-being of everyone that interacts with that environment. And this is particularly important because with people spending 90% of their time indoors, the quality of that environment would affect their health, their wellness, and their productivity significantly. Meaning that if the indoor environmental quality design is poorly done, it will lead to reduced productivity, increased absenteeism, and decreased building value. So, to ensure that there is adequate compliance with the standards, uh, it is important to categorize spaces based on occupancy, the frequency of use, uh, and individual, versus shared space. Additionally, spaces that are densely occupied, that is area with more than 25 individuals per 1,000 square feet or than 3 square meters, they require additional attention to maintain optimal indoor air quality and comfortable conditions. It is important to note that adequate care should be given to spaces that will be accommodating a good number of individuals, such that everybody's comfort is catered for. And predictably, the triple bottom line benefits include personal comfort enhancement by maximizing natural daylight, natural ventilation, reducing CO2 and pollutant levels within the spaces, and of course, promoting cleaner and volatile organic compound free environments. Economical um, initial costs may be incurred, but you see, you're able to mitigate expenses through proper allocation of thermal comfort and lighting controls, which now decrease your expenses associated with replacing contaminated materials. So it's a win-win at the end of the day, it's a win-win. Socially, occupant health is protected, productivity levels are increased, and the absenteeism is almost eradicated. Right, so the IEQ category focuses on sustainable measures that enhance the triple bottom line. The subject will include indoor air quality, like I mentioned. It will include lighting, and it will include occupant comfort. So we'll take them now, topic by topic, as we progress with this lecture. So let's start with indoor air quality. Maintaining indoor air quality is vital for ensuring the comfort, the health, and the productivity level of building occupants. In achieving this, the goal is to limit pollutant sources, provide good levels of fresh air, and follow the ASHRAE standards for the ventilation rate procedure. Despite the higher energy consumption needed to achieve these standards, it's a necessary trade-off for ensuring a cleaner indoor environment that positively affects people's health and well-being. It's also important to know that some areas in our buildings are more prone to hazards, to hazardous substances, to contaminations, and so on. So, which means they will be requiring special treatment to avoid exposing building occupants to polluted or contaminated air. And to achieve credits more efficiently, you need to have an environmental management plan for indoor spaces that can be implemented. This plan would include a list of potential contaminants that you've identified that will enter the building due to the activities around it. It will also include the specifications for low emitting materials and products to be used indoors. It will also include measures to safeguard materials and products during the construction stage, and how you intend to schedule cleaning activities during non-working hours to minimize occupants' exposure to dust and possible chemicals. So essentially, emission source control, ventilation improvement, and then construction indoor air quality management plan are the major focus of the indoor air quality. Alright, now let's talk more about the emission source control. Engaging source control measures is very important for mitigating the creation of negative emissions. We need to note that every pollutant has distinct characteristics and properties coming from various sources. So below, we'll be looking at some of the most prevalent indoor pollutants. We have volatile organic compounds, um, which are gaseous substances that are emitted from certain solid or liquid products or materials that contain various chemicals that can pose health risks. And you find this in a variety of construction materials, for example, paint, as well as sealants, adhesives, coatings, furniture, flooring, carpet, and so on. So to reduce the presence of VOCs, you can identify and use low VOC materials and products, and which helps you to enhance ventilation. All right. Secondly, we have carbon dioxide. In the majority of buildings, humans are responsible for the largest chunk of indoor carbon dioxide. This is produced through respiration and metabolic processes. When these levels of CO2s are elevated, it is known to negatively affect the productivity of humans and, of course, the overall well being. So, it's important to keep in mind that CO2 levels that are above 1000 parts per million ppm can have adverse health effects on humans. So, you need to take note of some of the references that have been made to specific figures to define some range of what is acceptable and what is not in LEED, so that you can be able to speak to those questions when you come across them in the examination hall. And how do you control the carbon dioxide level? We have the CO2 sensors, which are incorporated in densely occupied spaces to help monitor the CO2 levels to ensure that they remain below the threshold that we made reference to, which is the 1000 ppm. This is important for you to take note of. Also, we have biological contaminants, indoor allergens like mold, bacteria, viruses, and other living organisms can cause allergic reactions when you inhale them. They can grow in high humidity or moisture levels. We find that they often appear on interior walls and window sills, bathroom caulking, and moisture can also accumulate in insulation panels, dry walls, wood studs, plywood, and other areas. So to reduce this, we are able to consider installing exhaust fans in rooms such as bedrooms, kitchens, copy rooms, so that they can vent directly outside. Additionally, we can increase ventilation levels uh, when necessary. These are part of the measures adopted to achieve. Yes, another form of contaminant is the ETS, which is the environmental tobacco smoke. And it's good to note that non-smokers are more exposed to the risk for some types of cancer from their exposure to tobacco smoke in various environments: home, workplace, and public spaces. So to lower the exposure to ETS that are present on indoor surfaces, ventilation air distribution systems and building occupants, LEED has instructed project teams to implement effective control measures. And also, beyond this, smoking indoors is strictly prohibited, and outdoor smoking is only permitted in designated areas so as not to expose non-smokers or other building occupants. All right. Also, we have formaldehyde. Formaldehyde, a colorless, sharp-smelling gas, which is a common volatile organic compound that is used in the production of construction materials. This substance is linked to the sick building syndrome, SBS, and it poses serious health hazards. Formaldehyde is extensively used in manufacturing walls, especially wooden walls, cabinets, furniture. Uh, is essentially used in creating the resin, urea formaldehyde resin. This type of resin has raised many health and safety concerns, and this has led to the establishment of load thresholds for urea formaldehyde resin usage in composite wood and agri-fiber manufacturing processes. In complying with LEED policies, urea formaldehyde resin is prohibited and is replaced with eco-friendly options such as phenol, uh, formaldehyde, and soy-based binders. So, outlawed urea formaldehyde resin. Take note of that for the safety and well-being of building occupants. All right, let's go on. Now we have radon. Radon is a naturally occurring gas that is found in soil and rocks. It's a serious health hazard and is known to cause lung cancer. LEED, in its mission to encourage sustainable and healthy construction practices, wants to minimize human exposure to radon gas and other soil gas contaminants. This is accomplished by introducing techniques that are radon resistant in building design and construction. For buildings already existing, a radon test is required to determine if an improved ventilation system is necessary. That is, if the result of that test exceeds some 4 PCM. Alright. Next, we have ozone, a colorless gas that reacts rapidly with other elements that are present in the air. Although ozone generators, home air cleaners, and office equipment are sources of indoor ozone, outdoor ozone concentrations are the primary cause. Continuous inhalation of indoor ozone can adversely affect the human health. So, to minimize exposure, it is important to filter ventilation air to remove ozone and also limit the use of materials and products that react with ozone and its associated oxidation products. Take note of this. Ozone is another very dangerous um, colorless gas that we must design against. Finally, we talk about PM, which is particulate matter. Uh, when it comes to in the environment, we need to consider the presence of particulate matter and the potential it has on the health of the occupants. PM 2.5 particles in particular are so tiny that they can enter the lungs during inhalation and they can stay in the air for extended periods. Sometimes they even travel very long distances. So that's another contaminant that we need to be mindful of in our projects, in our building designs, and in preparing our environment to be sustainable. Okay, now we've talked about how important the indoor air quality is to the health of the occupants of the space. And we also looked at some contaminants that that pose hazards and dangers to the well-being and the productivity level of building and environmental occupants. And let's discuss how do we improve indoor air quality. There are numerous health benefits associated with good air quality. And in ventilating our buildings, three methods, primary method exists, which is the mechanical ventilation, uh, the natural ventilation, and of course a combination of the two. To follow the lead guidelines, it is mandatory to comply with the ASHRAE 62.1 2010 Section 6 to establish the minimum required ventilation rate for the design of ventilation systems. Right. For naturally occupied areas, it is recommended to comply with ASHRAE 62.1 2010 Section 5. So take note of the two uh, reference standards that I just mentioned in relation to both mechanical and natural ventilation. All right. When we talk about enhanced air quality, this is a move to avoid the infiltration of pollutants and particulates through ventilation systems and open, which can compromise air quality. So it is important to implement preventive measures. Some of them include the entryway systems, enhanced filtration media in our HVAC ducts to prevent pollutants from entering the building, increasing ventilation rates is another effective strategy to introduce fresh air into indoor spaces. Also, monitoring carbon dioxide level can also provide valuable insights into pollution levels. And CO2 sensors are usually provided or installed in densely occupied spaces. We mentioned it before, but you have 25 persons or more. I mentioned entryway systems. Um, because of contaminants like dust, microorganisms, and other pollutants that can easily find their way into buildings through the entryway used by occupants and visitors. Um, there are entryway systems that LEED recommends. They could include grills, grates, or mats that can be regularly cleaned and maintained. According to LEED, the system should be at least 3 meters long in the direction of travel and must be maintained or serviced weekly to guarantee that it is functioning at optimum level. This is an example of an entryway system. Obviously, you can see that this can easily be maintained and is able to arrest some dust and some other contaminants away from the traffic into the space. I also talked about air filtration media. Remember, we're talking about enhanced air quality. Air filters are created to purify the air by capturing the solid particles and dust that more than bacteria. They are composed of fibrous materials, and when we select the best filter, this can lead to long-term savings because it will not need uh, frequent changes like regular standard filters. So, because of this, there's a reference standard recommended by LEED, which is that it must meet the MARV 13 MERV 13 or higher, or an F7 or higher equivalent. So this is important for you to note when selecting the air filters, and you should take note of this reference standards in preparation for your examination. Then we also talked about increased ventilation levels. It encourages project teams to enhance the ventilation system's fresh air intake through increasing outdoor air ventilation rates to occupied areas by at least 30% above the rates that are outlined in the ASHRAE Standard 62.1 2010. Um, this is determined by the IEQ B1, and it helps to purify pollutants and other contaminants from the air, which improves air quality. Take note of this expectation of LEED. Now, we have the air quality monitoring devices. It is important to gain insight into the surrounding environmental conditions because this will help occupants to make necessary changes in improving their surroundings. One way to do this is to detect and identify harmful pollutants. This can prompt changes such as increasing the portion of fresh air, replacing filtration media, or providing additional daylight. So, monitoring devices such as carbon dioxide alarms, volatile organic compound sensors, and CO2 sensors are important for detecting these pollutants. They can be mounted on walls, installed, on doors for optimal performance. Now, the construction in the quality management plan that we mentioned earlier is important. Um, this is the plan that details the steps to be taken in reducing pollutants and mitigating poor indoor air quality during the construction process. And one way to achieve this is by following the control measures and take note of these reference standards we are mentioning here that are recommended in the Sheet Metal and Air Conditioning National Contractors Association SMACNA IAQ guidelines for occupied buildings under construction. The goal of this management plan should be to minimize any negative impact due to poor IAQ practices. So by keeping work areas clean and safeguarding HVAC equipment and ductwork, final cleanup required before occupancy can be significantly reduced. Additionally, this plan will ensure a safer and healthier work environment for the construction workers. Very important, take note of the reference standards. So we talked about SMARTNA, so let's look at the strategies contained in the SMARTNA IQ guidelines to prevent dust particulate from infiltrating the duct systems. Certain precautions must be taken. These are the guidelines. Store all designated ductwork in a clean and dry location before installation. Now, upon or during installation, cover all ductwork openings with plastic to avoid dust and moisture infiltration. Thirdly, use plastic coverings to prevent dust and moisture from entering HVAC equipment openings. Now, if the HVAC system must be operational during construction, then you must engage the use of temporary filters that meet the MERV 18 rating as per the ASHRAE standard 52.2. Now, take note, this is not MERV 13 or F7 that we mentioned earlier, because this is making reference to temporary filters, not permanent filters. So take note and don't mix them up. And number 5, remove the temporary filters after construction is completed before occupancy. Take note of these steps under the SMART now strategies. Now for source control, um, to minimize the release of volatile organic compounds within the site, uh, the first thing is to identify potential sources and contaminated areas, and then taking appropriate steps for either maintenance or avoidance. And most of the time, these emissions come from adhesives, sealants, paints, and coatings. One way to minimize exposure is to use 100% outside air for ventilation, allowing contaminated air to be exhausted directly outdoors during the installation of VOC emitting materials. We also talk about pathway interruption. This is one way to effect source control. To prevent the spread of pollution between clean and contaminated zones, it's important to deploy dust curtains, temporary enclosures, and barriers. Don't forget, we are talking about the activities that need to be engaged with in terms of construction uh, stage of the project. These measures will help keep pollutants away and contained. Another way is to maintain negative pressure relative to other indoor spaces. And this strategy is considered to contain cross contamination and ensuring a healthy environment. Another important component of the construction in the air quality management plan is housekeeping. To keep construction debris and dust under control, you need to maintain good housekeeping practices. And one effective way to minimize the recirculation of contaminants is by using the HEPA filtered vacuum cleaner, and also employing wet cleaning agents that can capture dust particles more efficiently. And it's also important to schedule activities carefully to maintain good air quality indoors. This is to reduce the impact of activities that may be generating high levels of pollutants. It is best to carry out those activities during off hours. Okay, so the idea of this is to ensure that activities are scheduled in such a way that the health and the safety of the construction workers are, is preserved and protected. And these are strategies that can be engaged to promote peace. Okay, we also have flushing out. To ensure indoor quality meets the LEED standards, a flushing out process is required before the building is occupied, that is after construction. This process involves the circulation of air throughout the building to eliminate pollutants such as formaldehyde and volatile organic compounds. Projects must adhere to a construction indoor quality plan which mandates specific thresholds to clean the air of contaminants, to cleanse the air of contaminants. To endpoints in LEED, a total air volume of 14,000 cubic feet of outdoor air per square foot of floor area must be supplied, and this is while maintaining a temperature of at least 60 degrees Fahrenheit and relative humidity not exceeding 60%. Take note of these figures. You possibly come across them in your examination. There's an alternative approach to flushing out. It's captured here. Take note of it and ensure that you are well informed for the interest of your project and, of course, for now, in preparation for your examination. We have the air quality testing, which is to guarantee the maximum permissible levels of pollutants within the space are not exceeded. This is to be done before building occupancy. This test to measure the concentration levels of contaminants once construction is done, and the project team have to clearly outline the method used to identify air pollutants in the air within the indoor space. Formaldehyde, particulate matter, total volatile organic compounds, and so on are some of the contaminants that require analysis. Take note of that. We have green cleaning. This is essentially about establishing a sustainable cleaning plan. If you are looking to adopt environmentally friendly cleaning practices, the first step is to develop a green cleaning policy for your building and its premises. The policy is expected to cover the procurement of cleaning equipment and materials. It should include strategies for promoting cleaning measures. It should include how you want to do employee training, what are other safety guidelines, and opportunity for occupant feedback. It is especially crucial for existing buildings to implement green cleaning measures to ensure that safe and appropriate materials are used indoors. Right. Now, having exhausted the subject of indoor air quality, we will talk about lighting. The productivity and comfort of building occupants can be greatly improved by a well-designed and well-illuminated indoor environment. High-quality lighting fixtures can help to eliminate distractions and foster a sense of belonging. Natural lighting, or what we call daylighting, can also help connect occupants with nature, help to promote healthy sleep patterns, you know, and reduce dependence or reliance on electrical lighting. In addition, when you give occupants control over their indoor environment, uh, it enables you enable them to adjust to their liking. You can boost their productivity and increase their satisfaction level. So under lighting, we'll talk about daylighting, we'll talk about interior lighting, and as well as lighting control. Let's start up. Daylighting is a technique that regulates the amount of natural light, direct sunlight, diffuse skylight that goes into a structure. The goal is to reduce electricity usage, conserve energy, of course, reduce air pollution, while also improving productivity levels. Now, when you talk about a complete daylighting system, this is not just about windows and skylight, it also includes lighting control system that responds to ambient lighting levels. Direct sunlight that goes into a building's openings, on the other hand, causes glare and excessive heat gain. So this makes it unsuitable for interior lighting. Skylights, on the other hand, provide a desirable natural light that is evenly distributed and free of glare and direct sunlight. So it's crucial to know that the availability of skylight is dependent on the environmental conditions, such as the sky and atmosphere. So these are all the measures that constitute daylight. Massing and orientation. Daylight is crucial for passive architectural design because it imparts visual and thermal comfort. So efficient daylighting involves optimizing larger structures for lateral window illumination and promoting expansive views through streamlined profiles, central courtyards, and taller windows. East-west building orientation minimizes glare and also ensures consistent daylight utilization. So this talks about how the management of the building mass and the building orientation can promote lighting and thermal comfort. Okay, let's go ahead. We have skylight and solar tubes. Skylight on rooftops increase indoor natural light, promoting daylight dependent healthy environment. Safety glazing is also recommended, and understanding properties like U value, shading coefficient, and visible transmittance can enhance thermal and optical performance. Solar tubes, another daylighting system, captures sunlight and brightens indoor spaces while reducing electricity use. You're going to see a picture of what this looks like in the next slide. So these are ideal for areas like corridors, stairwells, bathrooms, and closets where traditional skylight may not be feasible. You also have light shelves. This is essentially to control glare from direct sunlight. So light shelves are horizontal surfaces that reflect light upwards. Uh, they work best, you know, on sun, reducing glare while improving light uniformity. It's important for you to know that uh, the choice of materials for some of these measures will depend on the structural strength, the ease of maintenance, some other considerations that may be peculiar to the um, building owner or the client, consultant, or designer. You can see some pictorial representation of what lectures look like, and of course, what is other tube installed on the building roof um, looks like. Okay, so let's make progress. Daylighting simulation is a scientific management of natural light to reduce artificial lighting, to lower carbon emissions, thereby improving occupant well. This involves computer-based calculations that assess natural light levels under different sky conditions, providing some kind of aid to the architectural design. Factors considered include direct solar penetration, luminous distribution, and so on. So integrating this process with the building information modeling tools allows us to have precise adjustment to window to wall ratios during the conceptual design phase, thereby optimizing comfort and improving energy efficiency. Interior lighting. Integrating energy efficient lighting fixtures into your building operation can lead to substantial savings in electricity costs. And not just that, it may also uh, have positive impact on the occupant's emotional well-being and productivity level. You need to take note of the expectation of LEED in ensuring compliance, the defined values, the defined thresholds for us to have the best possible lighting quality. So the last subject under the indoor environmental quality is the occupant comfort, like I mentioned. Architects prioritize people and their activities when designing buildings. Right? They aim to create spaces that are comfortable, healthy, and safe for occupants to carry out their tasks. Could it be work, family related activities, or sporting activities? This design must prioritize productivity and well being by providing the best possible environment to its occupants. Green design principles play a critical role in creating sustainable structures that promote occupant comfort while minimizing adverse environmental effects. Thermal comfort. This requires that we regulate temperature, regulate humidity, airflow, and radiant sources to ensure individuals do not feel uh, relatively hot or cold. So there must be that state of contentment, with thermal comfort of the space. Uh, it's subjective, so it makes it difficult to quantify. But this relies on factors such as temperature, humidity, radiant temperature, air velocity, metabolic rate, and so on. And this varies from person to person based on their physiology or state of health. But the goal is we must be able to take everybody to that state of relative contentment. So when designing for thermal comfort, six crucial factors must be considered. Metabolic rate, which is the energy generation by the human body. Clothing insulation, which talks about the degree of thermal insulation a person's attire provides. Air temperature, which relates to the temperature of the air surrounding the individual. Right? Radiant temperature. Now, this is the weighted average of all temperature from surfaces surrounding the individual. And air velocity, the rate of air movement given distance over time. And the relative humidity, which signifies the percentage of water vapor that is present in the air. The ANSI and ASHRAE standard 55 thermal environmental conditions for human occupancy aligns the minimum standard necessary for acceptable indoor thermal environment. Take note of that standard of ASHRAE 55. Now, temperature control, as we gradually run up. Like I mentioned, temperature regulation is crucial for maintaining comfortable environment. It involves detecting and measuring temperature variations in a given area and adjusting it to the desired temperature. This capability allows occupants to control the air temperature, radiant temperature, air speed, and humidity in a shared or individual space. One of the most common methods of regulating temperature in a room is the use of the thermostat. Is to continuously evaluate the current room temperature and adjust the heater or the air conditioner to raise or lower the temperature as per, as per the user settings. The part of occupant comfort is acoustic comfort. This is because we need to cancel out unwanted sounds which can disrupt and intrude on indoor spaces. There are different solutions that are proposed. And LEED has also established thresholds for proper acoustic design in classroom, which is geared towards facilitating communication between teachers and students. And finally, we talk about visual comfort. Alright, so thermal comfort, which has to do with heat levels, acoustic comfort, which has to do with sound levels, and also visual comfort. Visual comfort is also crucial for a comfortable and productive environment, providing sufficient, well balanced, and high quality lighting, as well as access to good views, can be achieved through incorporating natural daylighting with efficient lighting fixtures and control. Quality views help to establish a connection between the occupant and the natural world. Factors like direct line of sight and unobstructed sight contributing to the quality of views. In all, there must be a way to measure occupants' satisfaction with their indoor surroundings, and this is by conducting a survey. The answers to the questions posed is then used to evaluate the building's heating, ventilation, air conditioning, acoustical, lighting, and cleaning system. The results can also provide insights on how to improve these systems ensuring that the building occupants are comfortable. Feedback is very essential to driving improvement. So that's a lecture for indoor environmental quality. Thank you for staying with us. I will see you in the next class. Bye.